What are the secrets of successful software architects? Let's what is this about? Hello, I'm Chris Athanas. I'm a KMP developer. That's going to be closed up. Said tech support. They said they're coming out on Tuesday to fix it up. We're gonna do a watch along with this. I've not previewed this. I don't know. I just saw the title. I was like, oh, this looks interesting. Let's see what the successful architects have to say. And they should have a body of work, a lot of successful projects, and things we could point at and look at. Let's go ahead. Ah,
the way that I've started
change.
thinking about the definition of quality in modern systems is our ability to change it. Because my engineering shtick at the moment, where I'm trying to promote the idea of software development as an engineering discipline,
What
applying
does that mean?
scientific style thinking to solving problems. It seems to
Okay.
me that starting out, knowing that we don't know all the answers yet, is really important. Assuming that
Yeah.
whatever answers we got are probably wrong and may change.
Business people don't like hearing that though. Business people, the MBA guys, like, what do you mean you don't know how this is going to work? We don't know yet. That what we're doing, we're trying to figure out a thing to get something that we can put in the factory to pump out as a widget. What do you mean you don't know what it is?
And maintaining our ability to evolve our thinking and our understanding is how we get to these more complicated systems that we've been talking about. So
Piece by piece, experiment by experiment, try after try. You're lucky, chance, having a culture that wants to get there and not putting up roadblocks every 5 seconds to keep their current fiefdom going. All this stuff, it's like not really it's never the main thing. It's like all these little side issues that just makes it just annoying. Let's keep going.
for today.
Yeah, he mentions two very important words there, right? It's like the uncertainty, the change, and also the complexities.
I've heard this guy talk once before, but he's a little gallopy, he's a little bit salesy, a little bit markety, planny, a little bit hypey, a little bit comfort circuity, book writing, get you in a training program, selling a course.
So I have some quite some thoughts on this one. The first one is both of us you mentioned at the beginning, right? We come out of sort of I don't say the birthplace, but probably sort of one of the early places where agile, hit the mainstream, right?
Yeah.
Agile.
What does that mean? What are you talking about? Which agile? are you talking about the manifesto, like the idea set, or the training program, TM registered conference book course training agile?
Agile development is very much born out of this insight, right? If I know all the answers and nothing ever changes, I don't need to be agile. Just write it down, I build it.
Right, we would be in software if that was the case. Kind of like we were all a bit kind of beyond this at this point. We're just like, how do we keep these projects from being unstuck? It's like, well, here's the thing I keep on harping on. It's like, this is trade secrets. How to put projects together and have people together that are motivated and have a culture of people that want to actually make things happen and not put impediments in the way that they keep their fiefdom of I forgot the printer kingdom in this canon and I will not let it go no matter what. And it's like, well, we're kind of people aren't printing out as much as they used to. It's like you have to go different market. You're not gonna have the consumer base that huge. No, we will die on this hill. It's like all that type of stuff. That's a big die. You have to look at it. Well, that's why the startups can come up and compete with companies that are keeping those fiefdoms going, which is as soon as you get a company going, there's gonna be fiefdoms. That's just how it goes. It's just humans.
I'm done.
Yeah.
Right now, that's not the context in which software is being delivered today. So hence, we are very fond of agile methods. And what cracks me up is that sometimes
Whatever
people
that
come and say, "Oh, I don't need architecture." Say, "Oh, you're an architect. That's very nice, but I don't need you because I'm agile." I'm like,
Yeah.
"Oh, that's
Well, that's okay. It's partially true, right? This is a nuanced thing. He's trying to make it a black and white thing. It's like you either pick agile, you pick architecture. It's like, no, man. No, architecture is just how you were going to approach a problem. So you first of all identify a problem that you think you can use software tools to address and have and I know this is crazy. Have a market of people that are kind of asking for this solution or somewhere around there. You've like got an insight somehow by being a tinkerer, a hobbyist in this field, or somehow like working in it for a year or two, and then you have an insight and you get together. It's like you can't predict where this stuff comes from, right? So you've got a problem, and it's your architecture is how you structure the solution to deliver the value to the customer that you've identified that has the problem. That this is like a newsflash to people.
It's quite interesting because if you're agile, it means you deal with change and uncertainty. Like, oh yeah,
true, you have to be able to change it and go through because we don't really know at the beginning if we're going to even have success. It's really kind of like, especially the adventure-driven stuff I'm pushing forward as a comparison to agile. It puts it up front as like we may not succeed. We probably won't. I know you don't want to hear that, but that's how software is. If we're trying something new and we're going in a different direction and they're trying something that no one's done before, there's a pretty big chance we're going to fail. I don't know if you know the track record, but it's like, no, you have to have a way of engineering the solution. It's like, no, dude. No, a lot of this stuff is just luck. I have to tell you, as much as all your effort and all your skill and all everything, if your timing's wrong or you overdid it and you missed the window and there's somebody else doing something else and a 2.0 of that and people are already buying that and you don't have a customer base because they're using this other thing that was like 3% better. All this stuff is just kind of random.
Lots of change, lots of uncertainty. I'm like, perfect. So does architecture, right? Because if you don't have change and you don't have uncertainty, you don't need architecture either.
Well, you have to have the architecture that supports the changes, because the changes is the thing that we're going to be dealing with. So not just writing it and reading it, it's like being able to read it. So we don't get to the rush into the writing. Oh, build it quickly, write it up, jam out the code. But then we find that like most of the time what we're doing is reading other people's code. So it's like, okay, so it's not being not getting the code out immediately. Maybe that's a 1.0, right? But the 2.0, we're going to try and make this thing readable, understandable, extendable. But no, we just got to put more features on it. We're feature factory the hell out of this thing. We got to keep up with the competition to make the next round. Funding.
So first big insight is really agility and architecture go hand in hand to deal with a world that has high rates of change and high levels of uncertainty. They go together. They're not opposites at all. Agile is the steering wheel, architecture is the engine, right?
I mean, but is this how we do it in practice? Are you proposing this? Do you have a methodology that lets you have this happen? Can you communicate? Engineers understand this. We're all on board with this about the engineering channel. But how do you communicate this to the MBA, Harvard MBA stockholders who've been told by the people in charge that every business is just a widget business? That all you have to do is plug in a Harvard guy into a widget business, and we got pure success. And that was true from the 30s to about the 70s, 80s. But then this other thing came on. It's like what we produce, like the thing we're actually producing at these widget companies, is actually quite important. And we're now going through a rapid pace where we're going to be going through a lot of this stuff because people have figured out the engine is not the Harvard MBA management style. The engine is this innovation of tinkerers, goofy weirdos coming up with all kinds of crazy ideas. Most of them failing. Even the big ones, even the big boys, Polaroid. They thought they're going to do a little chemical-based video system. And they thought they were going to really scale that. And they actually at the same time had the digital technology that they've invented that let them just slip through their hands. They just were not on board with that. And it's just funny how it's like, they had it. That company had it. Polaroid had it. They had the first digital camera, and they stored on cassette tape, which is crazy. But still, they had it with CCDs, the whole 9 yards, and they let it go. So even if you got the innovation and everything at the company, it's like the company structure is like, fuck you. No, we're not doing this. Let's keep going.
Make sure you move in the right direction. So that's a common misconception. The other word you said, though, is the complexity. We said, good architecture is making systems ready for change. Yes, and this is absolutely.
Is it? Is that what we? Because I thought about the micro. I thought it was this. What is it called? Micro. Hold on. What do they call this stuff? Microservices. Sorry, services, microservices. How you decompose your problem with all these little buffers. I thought it was about the monitoring and the building it up and scaling it up and down and getting massive amounts of adoption hyper quickly, viral effect. No, it's about creating ready for change. I have not heard this from anybody I've worked for. They're like, how can we get more features in this thing? Not keep how do we architect a system that can change and modify from whatever thing we're going to get into? I've never heard that. There's never been a thing. It's like, well, can you fix our legacy code? Our legacy team, they all quit. Can you just go in there and put a couple tweaks in there? Could you just fix a couple bugs? We make it scalable to make it changeable. No, that's going to be the next wave, right? It was as the software industry realizes that AI is not going to solve our problems, we're going to actually have to start looking at these things as the most important part is the readability, understandability, so you can look at the code and understand what it's doing. Documentation of this stuff, how it's put together, why we're doing these things this way. and have that integrated in somehow into the systems. Like, so when you look at a piece of code, you're like, what the hell was you talking about? Why is this doing this? So you have a little pop-up video of somebody going, yeah, so this is pretty weird. I know this here, but this is because of this thing over here and this part of this contract, this service level agreement over here. And I know it looks crazy, but that's what goes. Then somebody goes, oh, okay. Some of that tacit knowledge is normally stored in the group, can somehow get captured. But even then, the amount of tacit knowledge is not going to be kept in video. So we are not going to be able to get away from humans identifying problems that other people have and unique ways of serving them. We're not going to get away from it. And then how we build these things and maintain these things is if it's a real product, right? So if we get to the point where we actually have some sort of customer base, yeah, then we can start talking about how we maintain these systems, like in version 2, version 3. But version 1 is always going to be a mess. Let's just keep going. I got the wrong button.
True, but there's always a secondary effect, right? And usually the secondary effect is a negative one. So if you make a system ready for change, it's easy to increase the complexity, right?
Yeah,
but
for sure. Well, I mean, that's one part of it, right? That's just like, oh, I have more features, right? I guess that's true. If that's really what we're doing, is that we're just become feature factories. Okay. I mean, it's very common. It's pretty standard.
Everything to be changeable. Either you reinvent
everything turns into what a Jira. We got 1,000 little budgets. Is this just a to-do app? Is this just a to-do list? Yes, but we got all kinds of features. We got requests from big companies that need all these buttons and widgets. Is there any way to turn them off? No, they have to be all in your face at all times. It's like, all right, whatever.
The JVM, no need to do that, right? You can do anything you want, but you didn't deliver much value, right? So no need to do that. Or you drown in complexity, right? And this is where,
well, I mean, if you can't set it up for the complexity that you're adding, are you really managing for change and complexity? If the moment you make that ability that they just ramp it up, yeah, we have to have some kind of engineering around this problem. Like, how do you scale problems and that make them maintainable and easy to understand and easy to debug and easy to monitor and not crazy code shortcuts. Because you need a 2% increase in performance. We're gonna do a shortcut here, and like that guy gets fired, leaves. It's like, why are these things all connected here? And I make a change here, this thing over here breaks. We don't know. Figure it out. That takes 6 months. Great.
Industry, it's sort of a status, like a bragging right to have a law. So I felt compelled to also have my own law. So I call it Gregor's law, and that is
okay. See, these guys, all these architecture guys, this is kind of why we're annoyed with them. It's because they start to call these things their own laws when it's just an opinion, a way of looking, a viewpoint, a perspective, something to consider. No, it's Gregor's law. Dude, this guy is a total salesman. I just want to point that out. Let's keep going.
That excessive complexity is nature's punishment for organizations who are unable to make decisions.
What? No, the decisions are why the complexity gets put there. Okay, maybe saying no. How about that? In a zero interest rate environment, is it really people's saying no? Does that get you promoted? Does that get you the business deal? It's like, no, we can't do that. That's impossible. No, so the answer is yes. We're going to do everything. Let's add every feature. Keep going. We only got about 4 more months on this thing.
So the game is that, yes, you want to defer some decisions, right? You want that ability to change, but that deferring has a price, and that price is largely complexity. So
I mean, I guess that's one price. Is it the only thing complexity? Is it really? Can we design a system so we have a problem in mind and not just some generalized solution that's looking for a problem, looking for a market? Can we have something that somebody's asking for and we can hone in on that? Why does it have to be this complexity adding features all of a sudden thing? It's like, can we just talk to the customers more and really give them what they want? It's usually something better, like something more stable, more refined, simpler, more vertically down niched into their whatever problem that they're having. I'm sure there's the ways of making these things that way, or segmenting out those people that are not your group and then really focusing on your group. No, we just got to go for mass market. Okay.
And as architects, we find ourselves right in that middle. Like, basically, which things can I lock down that bring my complexity down, but that afford me future ability to change? Right?
Yeah.
Simple examples, right? So let's say people writing software and we don't know what languages they're going to want to use, right? Or they can't agree, or it's going to change in the future. Like, okay, I make a services architecture and I make common APIs.
Yes, okay.
Right? Mm-hmm. So if you have common APIs, right, the next service can be written in whatever language. Quite honestly, though, well, two main thoughts on this. On one hand, it's one of those classic maneuvers where taking some choice away gives you more choice. Right?
Yeah,
I force you to make common APIs, and I force you to use JSON and OAuth and HTTPS. Right? I lock many things down.
Okay, yeah.
Being sort of the old enterprise.
Yeah, you got to have the boundaries between these things have to have a lockdown. I mean, what do you? Those are all changing. What are we back to again? We're just doing slop more. Okay, let's keep going.
Architect here, right? I standardize some things, but it doesn't take your choice away. It actually increases your choice because now you can mix and match. You can deploy.
Right. If you have a standardized electrical plug, you can plug in all kinds of stuff. And if you don't change the plug arrangements, you can have all kinds of devices, all kinds of things plugging into it, as long as you don't change the API. Yes, this is very well known. Let's keep going.
Cloud, you can run here, you can run there, different languages, right? So first thing is, it's a classic maneuver of making some decisions enables others, but also, to be fair, I increase complexity a little bit, right? Now you need an API layer, you have partial failures, retry.
I mean, you can't just reach in directly. Yes, it's much faster to go if you want to go get a sandwich, to jump the line, get behind the counter, get the bread, slap the meat on, slap the mustard on real quick, slap that together, put your money in the till, dial it up, put the numbers in, put the number in the till, give them the money, get your change back, and then get out as you skip the line. Yes, it's much faster, much faster. But that's like, are you still using a service like that? And are you gonna make everybody go in there and jump the line and go make the sandwich behind the counter? Is that how we're doing it now? So just jump the line, it's fine.
Idempotency out of
that doesn't cause complexity. Yeah, that's where that's the way you think about these things. It's like, well, if you're gonna have to reduce complexity by, you're only gonna train certain people to do the sandwich making, and they're gonna be as efficient as possible. Not as efficient as you jumping behind the line, Mr. Expert. C++, we use static pointers.
Sequence messages. You have things like, in JSON, the field.
No, we're going to access the database directly. We're not going to go through an API or some kind of thing just because we need performance. Yes. So the decision for more performance is always at the cost of, holy shit, we can't fix this. It's all broken. If I touch this one thing over here, 65 things break over here, and I can't. And I try and fix all those things, and then 48 break over here because everyone's had the same idea to go in there and get it. It's like, guys,
is missing. Is that the same as null? Is that the same as
for performance?
Empty string, is that right? All the little fun stuff we deal with all the time. Those complexities we just all injected into our system. So a couple of thoughts to this. On one hand, as I said earlier, I have a hard time with having a definition for architect, and the reason is I have many definitions. So
how about the guy that's found a problem that he can find that he has an idea of a solution for? It's invention, it's design, it's taste, it's culture, it's context, it's caring about something to spend your life energy on, that more than anything else. I mean,
the definition for
architect. It's like someone who's got a solution to a problem. He's the guy that kind of, I've been finding solutions to problems to people. Well, in this particular context with these particular tools, there's other people that have all other things, like a gunsmith. He'll take a gun in and he'll fix it for you, and you don't have to know anything about it. It's like, I got a broken gun here. It's like, okay, I'll take it for you. I'll fix it up and he's a problem solver. He's an architect of the gunsmith, right? I mean, it's the same stuff. We're doing the same thing. So, no, I'm an architect. Every time you come up and said, I've got a problem on the computer, whatever, you're the architect of that solution. It's like, okay, guys, let's not get ahead of ourselves. Gregor Law.
Architects is your option traders, right? Basically, what choices do I take away? Because I gotta take some choices away, otherwise I drown in complexity.
Gregor's Law. Course.
So which choices do I take away, but what choices do I gain in return, right? That's sort of the
trade-offs. There's no solutions. There's no solutions architect. There's only trade-offs architect. How much is it going to cost? Because we can solve any problem, right? We can get to the moon, whatever. But how much is it going to cost, though? That's always the question. Like, well, you're asking the price? Ooh, it's going to cost more than you think. And that's what these Harvard MBAs want. They always want to know, because that's when they got to punch into their spreadsheets. How long is this going to take? That's why this whole estimation thing was like, so how long will you estimate it's going to take Unix to be developed from 1940? Well, what are you talking about, Unix? It's like, well, how long is it going to take for someone to wander in the computer room and start using our stuff after hours, and then come up with and find an old CPU sort of hanging around somewhere that nobody's using anymore, and then he writes a disk access program on it, and that turns into an operation. How long is that going to take? I don't know, 30 years? I don't know what you're talking about, sir.
Classic role of the architect. And the other way of putting this is, so we are sort of the flexibility versus complexity balancer.
Oh
Right?
my
Like how
God!
much
You mean You mean the trade-offs? We have to manage trade-offs and guess, and then take the heat when we get it wrong, or not take the heat. Oh, it was just those damn developers. We got to get developers. Maybe we get some AI developers in here. They can write the code that the architects have designed. Gregor Law.
ability to change can we have, and how can I do this without complexity, running, spinning out of control? That's another
Yeah, of
key role
course.
that architects do.
Yeah, absolutely. And again, we are kind of in 100% agreement and talk about it in slightly different ways. But it's interesting. So my one of my foundational ideas in terms of software engineering principles is the idea of managing complexity. So making those choices
of course,
that allow us, give us those freedoms.
The unhappy path is chaotic and crazy. It's the amount of things that can go wrong. Even just a simple operation is insane. Yes, and all those edge cases when things go wrong and things are screwed up. Yeah, man. What are you talking about? Yes.
But as you say,
managing complexity, but also trying to access and solve the problem for the customer. This is one of the things that these guys have a hard time sometimes believing that they're kind of like, what is the customer? Where's it talking about the customer and their issues? How to talk to them? How to get the information out of them so we can serve them better? Where's that conversation? It's just barely ever had. It's a little complexity and the architecture and the languages and the APIs. But where's the customer, man?
The income work. So I have some examples in my book where it talks some little code examples. And
I think what happens is these guys get hired on after some business guy has found the customer. He's like, oh, he's gone to the sales calls with all these objections. He's like, well, if I can get these guys together and meet all those objections, then I can put that together and profit.
And I point out that
so maybe these guys don't actually find the customers. They haven't never done that thing. They're really like talking to those guys. They don't know what they're talking about.
If we're going,
they're like annoying and they ask for impossible things.
To go for more modularity, better separation of concerns, and so on. There's probably
like removing the buttons on Jira, so I'm not cluttered with stuff I don't need and use, it's just annoying and strange and odd. And which one do I have to remember to click as I push through this ticket? Is there a way to turn that off? Never heard that question before. Okay.
Probably end up with a little bit more code, but it makes the system as a whole more flexible and you can deal with it.
Right. Having APIs is going to have more code, and it's going to cost more processing power because you have to go through the API to get to the database than just going right to the database. Yes, Dave Farley. Yes, you have diagnosed it correctly.
Different ways, and I'm talking about the trade-offs between those, those different ideas. I'm certainly in my head as you were describing that. That's what I was translating it into. I think we're talking about the same idea there. This trade-off between those. I think that's an insight it took me a while to get to, but you've stated it really nicely, which is that idea of the constraints are a tool that we use to give us those freedoms in other areas.
Right. Using an API allows us to scale stuff and make things separate out. And so when we change one thing behind the API wall, we don't have to go hunt around with it's changed to 55 where it's accessed directly 55 other places. Yes. So we have an increase in complexity one place and then a massive decrease in the complexity in the other. It was like it's just glossed over. It's like, no, this is the key thing.
So there are parts,
and you have to consider the performance goals. So you gotta do caching and shit. So that's the number 2 problem in the 3 problems of the number 2 problem in the 2 problems of computer science is naming things, cache what is it called? Cache invalidation and off by 1. So there's the 2 problems you have. Anyway, here we keep going.
Parts that matter more it seems to me there are parts that matter more in the design of software than other parts. I don't, the idea of something like modules or APIs, the boundaries between them, are more important places in the code than the internal detail of the implementation.
Correct, because if you're going to bypass this API thing, you're going to go directly back to we're back to the mess of complexity again, where everything's interrelated with everything, and we have all kinds of different plugs, just like we have with Android, going through the series of all the different USB style plugs. All of them doing exactly the same thing. Yeah, so it's like, okay, USB-C, that's it, guys. They was like, we can't make any more cables.
It clearly has to work, but you should be able to change it in a whole variety
So
of
the
ways.
cable manufacturer's like, but everyone's like, okay, thank God I have to freaking swap out 15 different cables every 2 years.
Those more important places need a different kind of thinking, more architectural thinking, I suppose.
Mm-hmm. Yeah,
What does that
absolutely
mean?
right. So just well, two comments, right? The one thing is because it sounds a bit abstract, but it's like really important, right? This is at the essence of architecture, but it runs the risk of sort of being labeled as academic again. So that's why I like sort of real life metaphors. Now I worked in financial services, so that's why the options theory, right? Like options trading, right? So what's the strike price? What's the price of the option, right? I use that a lot with my customers because that's stuff they know from the industry domain. So if you can do that as an architect, make that translation, it really helps get your concepts
right. Talking to the customer in the way they understand, with metaphors they understand. Okay, so finally we have a guy that's like mentioning it, but he's mentioning it this way. It's kind of odd. But his point is that yes, if you can talk to your customers in their domain knowledge and you start to understand their domain, that's way better than you using your technical jargon and generic database access SQL stuff and not talking because if you want don't you want to serve your customer, you gotta have to talk to them in their language and with their concerns and with their mind view and their worldview, how they conceptualize the problem, so you can. They're the ones working this thing. They got some other way they're doing it now, and it sucks. So, what sucks about it? Can we make it better, faster, stronger, easier, more fun? I don't know. We probably
across because it's not so easy to put it in the right words. And the second part of it is, of course, I'll bring this back to the architect elevator. So let's say you're faced exactly with one of those decisions, right? I can make this more modular, so that affords me a bit more changeability, but I pay some complexity. Like which way is better?
Yes, an API layer is going to add complexity. It's going to add some performance hits. Yes. So the set of problems when you do that are the set of problems of cut off of every damn thing interrelated with every damn thing else, and everything gets stuck. That problem set gets cut off. So you have another problem set of, damn it, I just have to go through the API and there's a performance hit. I'm not getting my request for 0.2 seconds slower than if I went direct.
You, as a technical person, you cannot answer that unless you understand the business and the business strategy and the variability up there.
Right.
Like you cannot make a good decision about this without understanding the levels above you. And I have a fantastic example, right? Insurance business, we once wrote a.
Yeah, it's surprising this should be stated. If you're a systems architect, you don't understand all the business requirements. Well, you don't always do because there's a lot of them are hidden. A lot of them they don't want to tell you. They think that you might steal it. Or they're doing some shenanigans and they don't want to quite. They want to like slip it under there without you detecting it.
Sort of tablet, really cool stuff, digital, where people can buy insurance, right? And it was really successful. You put your coverage in, and then it tells you how much your premium would be. 2 months later, or shortly after, great success, the business comes like, oh, we want to do this in the inverse, right? Because Southeast Asia, people have limited budgets. So people want to put in how much premium they're willing to pay. And you're supposed to tell me what coverage you can get. And people are like, oh, it wasn't built that way. Right? And I went to the business folks and it's like, well,
wow, that sounds like a real hard problem to solve too. Just to display the data in a different way. These guys. Okay, whatever, man.
Did you assume that this was like the most obvious next thing? They're like, yeah, of course, totally, right? It's like either do it that way or that way. It's like same thing, right? Of course, right? But that haven't made it to the technical folks. Of course, in the end, we like cheated up.
Why would it? We're kept in the dark about all this stuff. We're just given tickets to go punch. We're not in these meetings with the architects. We don't let the lowly programmers in on this crap. Yeah, here's the architect talk. Pretty big deal. You can't just get involved with this and you just be listening in on these conversations. We'll give you tickets on Jira.
We out with like some iterating and bisection interpolation, right? You can sort of, right? We like sort of.
And we're shocked, I say, that we didn't see the next obvious step in business. Shocked. We had no idea.
Put some screws on the front side, right? And the end made it work. But this was a classic example where the business says, of course, that's the next thing we're going to do. But the engineering team, and they made a really cool calculation engine, right? It wasn't like they just hammered it together. Right. They really put software engineering effort in, but without knowing what.
That's what you asked for. Because that's how you want it, right? Mr. MBA Harvard architect in the boardroom making big plans, big decisions. We don't need those lowly programmers in here where they're going to actually implement this stuff and might have some ideas about how things are done and are tinkerers and they got hired on because they're kind of into all this kind of stuff. No, 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 no. We don't want those people around. This is big boy talk. Okay?
What the variability points are. So that shows a very elegant architecture that's solving the wrong problem.
Yeah, exactly. It's very common. This is where architects get a bad name because they're all high in the sky, really focusing on the moment thing. Get all the specifications for that thing. We got all the programmers on our reins, and then you blame them for not seeing that there's the next obvious step is going to be this. You blame them, really? How about you take the blame, buddy? It's not them. It's you, Mr. Architect, for not communicating it, Mr. Big Boy Architect. You're blaming the programmers, really? You're blaming because they didn't architect it properly. No, you didn't architect it properly, Gregor Law. Is this a Gregor Law?
And that is without knowing what's going up here. You
How
cannot
would they, sir? Were they at the meetings with the big boys, the architects? You wouldn't understand. This is business talk.
The technical decision down here because
not like they all buy insurance themselves. They're using these type of websites all their whole life. Gregor Law is. You might want to stay out of this meeting. It's a little high level.
Guessing, and you'll be guessing wrong many times.
This clip was taken from my podcast.
All right, cool. That's cool. Anyway, I hope you appreciate my humor, giving these guys obscuring because they just talk like they're the best thing that ever happened. They don't take they have zero self insight to what's going on with why are they doing this? Why are their projects going off haywire? And the whole thing well, I'm an architect. Of course I know all the buzzwords and all those trade-offs. Of course I do. We don't need to let them lowly programmers in on this stuff. We're the big dogs. Give me a like and subscribe, and I'll talk to you later.